Hi, and welcome to According to Pete. In this episode, we're going to revisit my garage audio project. Took a couple of impromptu videos in my basement with my god-awful phone. One of them is detailing the mechanical aspect of putting the board together with faders and the Mega Pro board and the amplifier board. The second one is how I started to wire it up and my thinking behind that. So, no point in hesitating. Let's jump right into the first video. Okay, so I'm in my basement and I'm looking at my setup sort of like this. I got my amplifier here and my enable switch here, and that'll get set up on standoffs, I think, right about yay. And then I got my Mega Pro 3.3 here, and that'll get headers. So all the headers will be down underneath the circuit board under here. Derp, watch what you're doing, Pete. And these faders, those are made to be mounted behind something. And I'm not really going to have any room behind this board because it's probably going to be up, not quite flush, but it'll be, you know, close to the wall when it's ultimately mounted. So I think what I'm going to end up doing, as stupid as this may sound, I'm going to build a little thing that stretches sort of over the top of the two faders here, and another one at the bottom. So these things will actually stand off from the circuit board like that. Now I could actually just solder those tabs down on the thing, but then it's permanently affixed, and I like to be able to take my junk apart, so I don't think I'm going to do that. Anything else of note? I don't think so. The enable switch, or disable switch, will ultimately go back to the Mega Pro. Yeah, okay. So now I'm going to start putting this thing together. That's the end of that video, which was really badly done, poorly focused, and I'm looking off to the side. Terrible. In the next one, I have all that stuff semi-permanently affixed, but not permanently affixed. Roll it, dude! Okay, next installment. I've managed to mount all my junk, well, all my junk that I'm worried about right now, onto my through-hole PCB. Let's see, I'll start over here. We got the amplifier on some standoffs. I got standoffs on the main board. I've got the Mega Pro on headers all around, and that one header that's off-center. Yeah, I just jam in a header and make it fit. Yeah, that's what I do. Now the faders. I told you before I was gonna do do exactly what I did here. Now, make no mistake, this is janky, but it ended up working out really, really well. So, let's see if I can point and film at the same time. I got a standoff here that runs up to this PCB that goes to the mounting holes, right? You can see how that goes. And in the bottom, right, the prototyping board wasn't long enough, so what I ended up doing, let's see if I can get this. You can kind of see what is going on. There's a standoff under here that goes up to a PCB. Yeah, stay with me now. That goes back under here, farther than the end of the board, right? Then with a 4-pin male header, I connect the one underneath to the one on top that runs across the two mounting holes. And you know what? It's really solid. It worked out better than I thought it was going to, so that's pretty cool. Now, almost always, without fail, I never plan out my projects very well before I start, and this time is no exception. I didn't do a whole lot of research on the faders before I started doing this, which was stupid, but typical for me. These driver motors, right? I figured, what, 100 milliamps? No, it's like rated 400 milliamps to 800 milliamps. So, I need a driver. And that's what I have over here, the SN70, can I read it? 75441. Datasheet said the channel, or it was good for like an amp per channel, and it's got 4 channels on it, so that should work out pretty well to control the faders. The other thing of note, right, I sort of assumed that the faders would have like an audio taper on one of them, and then on the reference, right, right, because it's got two pots, right? It's got two variable resistances that are associated with that fader movement. And I figure, okay, one's going to be the audio taper, and the other one's going to be linear, right? Because they know you're going to use it as a reference for position, and they want to make it easy, right? Right? No, not at all. It's an audio taper on both sides. So, not the end of the world, but kind of a pain. I'll figure it out. Let's see. The other thing I might mention is that the pots that are on the amplifier, these are not audio taper to begin with. And so they tend to be kind of sensitive. Now, I probably don't need to do this, but I think what I'm going to do is I'm going to set the faders up in series with these guys. And the reason, it's purely aesthetic. I don't want to have this thing go only this high. Oh, geez, that's too loud. My neighbors are going to be mad, eh? So what I want to do is I want to desensitize them a little bit so that when I turn the volume up, I get to see a lot of movement. Hey, that's pretty cool. And then I can adjust it to my liking with those guys. And I don't think there's anything else to tell you. The driver chip, right? This is one thing I like about my prototyping work, is that I got plenty of room on that board down there to drop that guy in. Hopefully not sideways ultimately, but when I put it in, it'll be right side up, and a lot of space down there. Let's see. I might do, I probably won't have to do any other regulators. I don't know. I'm still sort of feeling it out. But the next day or so, I'm going to work that out the rest of the way, and I'm going to start wiring it up. So hopefully, the next time you see this, you'll see something more meaningful. Ha ha ha. Nice, huh? No, out of focus. No, it's an Android, and I'm like this far away from the thing. Did you notice my WEP key? Yeah, this is why I don't ever pretend that I've got anything more than about an 8th grade education. Not smart. Not smart. Anyway, so that's the physical setup. As you see here, I've got the board, and we're going to talk about this. I've got it sort of wired up, and we're going to talk about how that happened. And we're going to talk about the circuit and how I'd set up the schematic. So let's hit the board and let's talk about that. What we're looking at here, I got my Mega Pro 3.3 so that I can feed it 5 volts because my supply has 5 volts and 12 volts. It's actually got a 28 volt supply too. I don't think I'm going to use that one. But, so I'm going to feed this with 5 volts. I have my driver chip over here, the, what was it, SN75 blah blah blah. Yeah, that one. And this just illustrates how I'm driving this. Over here I've got my fader motors. They're driving off of 5 volts. Now, to address that for just a sec, if you look at the voltage spec on those fader motors, they are from 6 volts to 11 volts. Convenient, I've got a 5 volt supply and I've got a 12 volt supply. And the 28 volt. If I get really mad at it, I'll give it the 28 volts. But I tested these motors on 5 volts and they move kind of slow. They draw about 200 milliamps, give or take. The stall current on those things when you hold them is about 250 milliamps, so I'm not really worried about it. They do move, it's going to be fine. Now, what I have here, I just have my some digital lines that I've labeled, and I chose them almost arbitrarily. One going to enable line for channels 1 and 2, one going to the 1A line on the driver, and that same line gets split, and you see I've got a 2N3904 fed off the base from a 330 ohm resistor, pulled up to 5 volts by a 10K, and all this does is invert the signal. And this is so it gives it the bridge action, right? So if I've got this high, you've got 1Y going high and 2Y going low because of this. And if you have this going low, this one will go high, flips the direction of the fader. Simple, okay? And the same thing on the other two channels, 3A and 4A, coming from D4 and D5. Now, worth a note, but nothing I'm concerned about, is that, of course, this part is rated, I think its lower end was 4.75 volts or something like that. So you gotta, the logic you gotta drive with 5 volts. And I happen to be, yeah, 5 volts to the fader, motors, yeah, you get that. The logic this expects, and I checked it out, you know, the high level, 5 volts is the target, so I'm gonna have that covered with the inverter circuit to this one. This one directly is going to be 3.3, but according to the data sheet, that's still over the threshold, so I'm not really worried that that's going to be a problem. Here's the other thing I want to show today. What I've got currently on the amplifier, this is like one example of one of the potentiometers for the volume on the amp, right? Signal, and this is AC coupled if you look at that schematic. Just goes to this guy, and then it goes to the STA 540. Cool? As I said before, I'm going to leave these guys in the circuit so I can desensitize this thing so I can get a lot of fader movement and make it look cool, because that's 90% of what we do here. So this can't stay. So what's got to happen is I need to break that circuit. Check it out, they give you these funky little erasers that even sort of work. Check it out! So I break this one, and I do this sort of action. So this becomes my signal, and then I feed this guy down to here. So this becomes a series resistance, an adjustable series resistance, with the actual fader that I'm going to use. And so then this guy will come off of here like that, sort of, and go back up to, all right, rather convoluted, but you get the idea here. So this is what is actually going to happen with the volume control, okay? Now, the other fader side, right, because there's two resistances in that fader, what's going to happen is the tap to that guy is going to go straight to A0 on the Mega 3.3 volt, 3.3 board, which is 3.3 volt. Now, the top of this guy's got to be 3.3 volts, right? Because the window on this thing is going to be 0 to 3.3 volts. So obviously, you want the high voltage to be the same as what's running on that board. Now, also worth a mention is these grounds, okay? Now, this one is going to the amplifier board. So I'm going to run this ground straight over to the amplifier board. In fact, it's going to be tied directly into the pins that potentiometer is attached to. This one is going to go back to the Mega 3.3 board, okay? Do I have to do this? No, I don't have to do it, but when you get into long distances with traces and stuff and wires and such, you want your references, especially where audio is concerned, you want your references to be as true as you can make them. Otherwise, you can be introducing noise, crosstalk, ground loops, all kinds of weird stuff that make it real wonky. So this one's going to go back to the Mega board, and this one's going to go directly to the amplifier board in order to maintain that. And then A1 is going to be the other fader for the other channel. Simple. I'm not going to redraw that. The only other thing, the standby circuit. Okay. Now, if you look at the data sheet for the STA 540, they tell you if you give it a CMOS level on the standby line, which is, let's say, like 5 volts, it will turn off. Okay. Now, in this thing's natural state, I want the amp to be off. Okay. Because if I do something stupid with the code on this thing that causes the faders to go all the way up or what have you, I want to make sure that in an unknown state, this thing is off. And when this thing is not running code, the natural state of this guy is to be in a high Z configuration or an input configuration. If this is an input, this transistor is off, and the standby line is pulled high to 5 volts through the 10K resistor, right? To turn the amplifier on, I have to make a concerted effort here to put this line high. Set it to output, turn the line high, turns on this transistor, standby goes low, amplifier turns on. Simple? Simple. No, I don't pull it up to 3.3 volts, I pull it up to 5 volts. 5 volts is easier to get to out in the middle of that through-hole PCB. Than 3.3 is, but I could do it. Does it make a difference? The way I'm going about it is the higher the voltage I put on that thing, the safer I'm going to feel about it. And there are actually some warnings on the STA 540 datasheet that say, you know, don't feed this with anything that can supply more than a milliamp or a couple of milliamps or something. So, 5 volts will do, I'm sure. This is another 3904 because they're plentiful. 10Ks are plentiful. 330s are plentiful. You could build all of Western civilization with 3904s, 10Ks, and 330s, man, and maybe a couple of motorized faders for aesthetic appeal. Okay, here's the board in its current state. Look, I got my nice little fader action. The button's going. Okay. Now the top portion of each fader, like there's a bottom portion and a top portion, one that's closer to what I call the top. Top portions are for position reference. So I've got those with the brown and blue wires here strung over to the Mega Pro 3.3 board, and the references also, and they're on headers because I'm probably going to have to take this junk apart sometime because I haven't planned something out. The audio lines, which will go over here to the pots, are not connected yet, and my wires down on the references are a little short, although both of these go to ground, so if I really wanted to, I could just string those down to there and call it good, but I'm probably going to go the distance and actually go all the way over to the pots. These guys, this is a holdover from when I used to do, like, exclusively prototype work when I was a technician. Back in the day before I was an engineer. I used to make like big old things, like I'd take like thick gauge wire and you can see what I did here. I twisted it all up, I soaked it with solder, and then I pinned it to a board with a ton more solder. Doing so gives me a really good way to put like lots and lots of wires on that. This one's ground, that one's 5 volts, that one's 12 volts. 12 volts only has to go to one place. It probably didn't need to be like this. Why I do these things is, again, it's a holdover from back in the day because most of what I had was alligator clips. So you can clip onto this guy or this guy or this guy with an alligator clip pretty effectively. And you can probably tell I did this one first and went, well, I kind of like that, but and then I did this one, and for some reason I thought, oh, I'll just curve it over. That was dumb. Anyway, the third one is probably the best. It'll clip on really nicely to an alligator clip, and I left a lot of space here to get a lot of grounds on. So, your mileage may vary. Now, also worth note here, you see I've got my 5 volt lines. I've got a separate line going to and this is the mega board right here, and this is the driver chip, which you may or may not have seen when I had it right side up. And these are separate. Same thing with the grounds, okay? If you don't already know, this is called star configuration. Why do you do this? Well, let's see if I can explain this easily. It goes back to Ohm's law. If you have these things daisy chained, like in sequence, if I went like to the driver board and then I daisy chained over to here, the driver board or the driver chip will draw, I expect that to draw a ton of current, okay? And the wire is effectively a very small resistance. It's small, but it is resistance, right? So the more current you draw from that, the more voltage drop you're going to have across that very small resistance. So I do two things. I split them up and take them all the way back to the source, so I don't have any of that kind of weird daisy chaining effect. And I use thick gauge wire, so I don't have to worry about it. Now, this is sort of a corollary to the order of magnitude rule when you're designing stuff, which you may or may not be familiar with. It goes something like this. If you don't want something parasitic to be involved in your equation, in your ultimate equation of functionality, make it big enough that its effects are an order of magnitude away from the things that you're calculating with, right? So I made these wires big enough that I'm not going to have to be concerned with anything being a problem. That's what I did here. Under here is the driver chip, and these are the inverting transistors, which are just 3904 NPN transistors with a 330 ohm and a 10K ohm, and all they do is invert the signal. There wasn't a lot of room underneath the faders next to that chip, so I just strung them under here. And because of the standoffs, I got plenty of room, so that's not a big deal. The motors, I have not strung those over to the outputs of the driver yet. I will probably put those on headers, so again, if I have to take all this junk apart, it's not going to be a big deal. These are the signals over to the Mega Pro 3.3 board. So one of the things that I do from time to time is I'll braid wires, right? Or twist them up together to make it look nice, and people go, whoa, look at that, he braided his wire. It's really not that special. one thing to be aware of when you do stuff like that is crosstalk. This, like for example here, these two wires are the references, right? These two wires go to ground for both the left and the right channel, and there's audio going through here. So this is a really good opportunity for crosstalk. Am I worried about it? Not hugely. This is not a lot of current going through here, so I'm not expecting a lot of noise. If I was really concerned about it, if I was really a purist, I would separate these two and, I don't know, shield them and say a prayer or two, I don't know. And same thing for these guys. I will twist these up together, and it's like the tap and the high end and the signal in for these, but I won't twist these together, which is in effect what I did here. So you might watch that if you're into high-end audio. Don't try to institute or instigate or cause otherwise crosstalk in your signal. So there's the board as it sits today. First thing to do before I do anything else is probably check for shorts. When you do a project like this, when I do a project like this, before you hook up power, grab your own meter, power and ground. Make sure you don't have any shorts. It's not a guarantee because there are active components on the board as well, but it's a sanity check. Just make sure that when you plug in your supply, when I plug in my supply, I'm not going to start a fire. After that, get code running. So like load Blink onto the Mega Pro board to make sure that's going. And then work out the fader movement, get the faders going up and down in a reasonable way. And then set up a meaningful interface, probably a couple of push buttons that I'll put off on the side on that PCB there somewhere, so I can make the faders go up and down at will, and then wire up the audio and make sure that that functions. And after that, I'll start looking more seriously at like implementing the XB and getting that working across my phone and stuff, and then the display after that. So this is probably going to get nuts. So we're done for today. Thanks for tuning in. Thanks for watching. Thanks for being patient. Keep the questions coming. I swear to God, we're going to address them. You can put them in the comment section below, or you can email to feedback@sparkfun.com with "according to Pete" in the subject line. I'll see you next month. Bye.